first question says work out 25 to the power of negative 0.5. So first, let's rewrite this in positive power. That's going to be 1 over 25 to the power of 0.5, which can be rewritten as 1 over square root of 25, which is basically 1 over 5. And the next question says prove 5n plus 2 whole square minus 5n minus 1 whole square is always a multiple of 3 if n is a positive integer. So let's expand the bracket separately. 5n plus 2 whole square is going to be 25n square plus 2 times 5n times 2 plus 2 square, which is 25n square plus 20n plus 4. Now 5n minus 1 whole square is expanded. So that's going to be 25n square minus 2 times 5n times 1 plus 1 square. That's going to be 25n square minus 10n plus 1. Now if we subtract these two, I'm just going to highlight this over here, and we know that 25n square minus 25n square is 0. 20n minus negative 10n is going to be 30n. 4 minus 1 is 3. So if we factorize this, that's going to be 3 brackets 10n plus 1. Since it's being multiplied by 3, that means yes, the result will always be a multiple of 3. Rationalize the denominator root 3 over root 2. So what we'll do is we multiply the numerator and denominator by the surd in the denominator of the fraction, which is root 2. So that's going to be root of 3 times 2 over root 2 whole square, which is basically root 6 over 2. So when we rationalize the denominator, basically what we're trying to do is we're trying to get rid of the surd from the denominator. So now, as you can see in the final answer, the surd is only in the numerator, not the denominator. Find the equation of the line that is perpendicular to 3x plus y equals to 8 and passes through the point 1, 5. So that means we'll first convert the line into slope-intercept form, which is y equals to mx plus c. So 3x plus y equals to 8 becomes y equals to negative 3x plus 8. The gradient is negative 3 for this line. So since they're perpendicular, so that means if m1 is negative 3, m2 would be 1 over 3y, because m1 times m2 is equal to negative 1. This is the condition for perpendicular lines. And this is how you find the gradient for perpendicular lines when you have the gradient for the other line. So now that we have the gradient, we have the point, we can find the equation, which is going to be y minus 5 equals to 1 over 3 times x minus 1. Cross multiply. 3y minus 15 equals to x minus 1. 3y equals to x minus 1 plus 15. 3y equals to x plus 14. That is your answer. Then it says simplify 81x to the power of 8 whole power negative 3 by 4. So whenever you have a power outside the bracket and inside the bracket, what we do is we distribute the power with whatever the term is that is present inside the bracket. So it's going to be 81 to the power of negative 3 by 4 times x to the power of 8 times negative 3 by 4. So that's going to equal 81 is basically 3 to the power of 4. And x times negative 3 to the power of 4. Over here, we will have 3 to the power of negative 3. And over where we'll have 2 times -3, which is going to equal to 1/27 times x to the power of -6. So 1/27 x to the power of 6.